this computer. Okay. Okay. Now you can start.
Okay, I'll get going. So thanks for having me. I apologize for not being able to make it up there in person. I got back from the field all of Thursday and have spent the time in between trying to situate all the things that resulted from that. So um, I'm going to talk a little bit about what we're doing for those of you who haven't heard me talk about why, what we're working on and why we're out there working in the desert. And then I'll talk a little bit about where we were going and what we did and what we found, and a little bit about where we're headed. So um, it's great to talk to a group of avocational paleontologists like yourselves who are going out and looking for fossils. I really enjoyed seeing all of your show and tell, and if we're honest, what I'm doing here is a little bit of show and tell myself. So I'll share a little bit about what we're up to and what we're finding in doing it. Let's see here. Now my slide. There we go. Now my slide's going to advance. Okay. So I'll start off with the questions that are driving the research to give you a sense of why we're going where we are, and what we're hoping to do with the field work. I'll show you some pictures. We'll talk a little bit about some of the things that are challenging about the work that we're doing right now, things that are slowing down the pace of work a bit, as well as some sort of opportunities and ways that the work's being sped up and facilitated by some of the collaborations we have. And I'll talk about ongoing work, stuff that we've got going on as the summer continues. So if you've been around NARG for a little while, you might have seen the talk I gave a couple of years ago talking about the research at the front end of this project. We're working on a part of a longer project looking at the ways that mammals respond to environmental change, and particularly looking at the record in the Northwest, in Oregon, to understand how Oregon's particular geologic history has shaped the relationship between mammals and their paleo environment. So, the thing that is true of Oregon today, and it has been true of Oregon for at least the last 100 million years, is that it does not stay the same, right? It is a constantly changing landscape, right? It's volcanically active, it's tectonically active in the sense of mountain building and basin and range uplift and things like that. And all of that topographic change has some real implications for the way that the animals living on the landscape experience their environment. And I'm an evolutionary paleontologist. I'm interested in the evolution of ecology in mammals, and thinking about a landscape like this that's constantly being reshaped, where mountain ranges are going up and down, where volcanoes erupt and wipe out the flora over chunks of the landscape and so forth. Understanding how all of this constant geologic change affects the mammals on the landscape in Oregon is going to give us a really good understanding of the way that mammals relate to their environments. And we're comparing this to the much better known record of fossil mammals from the Cenozoic in the Great Plains, right? So there's a long history of work on mammals from the Great Plains. That lovely little fossil horse that we saw at the beginning of the meeting is one of the examples of a fossil from this well-known record in the middle of the United States. Oregon, it turns out, as many of you may know, has a really good record of Cenozoic mammals as well. Obviously, if you've been to the John Day, you know that we have actually better preservation of that particular time period than possibly anywhere else in the U.S. and maybe the world. And so we have some really exceptional fossils, some really important fossil sites, but our fossil record is not as well studied, in part because of all that geologic activity. Paleontologists can sometimes be geologically a bit lazy, and working in a landscape where the rocks are all broken and faulted and folded and complex can be really difficult. It's hard to keep track of where you are, what rock unit you're in, where's the next outcrop going to be that's going to have it, and so forth. And so it's a lot easier to do that in a place like Nebraska, where if you know your elevation, you know where you are in the stratigraphy. Doing this in Oregon requires like a good understanding of how the geology is working. And so it's often been a bit less considered. But if we're going to understand how landscape change affects animals, this is a great place to do it, and a much better place than the Great Plains. Not that we're biased in any way, you understand, as Northwesterners, right? So it turns out Oregon is actually a really phenomenal place to do this. And as an illustration of this, I show you a couple of maps. The one on the left there may be familiar to some of you. This is a map of Oregon's geology, courtesy of Dogami. Thank you to our state geologists. And the thing I want you to see from squinting at that geologic map is that a lot of the geologic units exposed at the surface in Oregon are in this map colored sort of yellow and brown and orange. So the coloring of this map is dictated by the age of the rocks. And those yellow and brown and orange units are all Cenozoic in age. So they're all from the last 66 million years. That's important because if you want to look at how Oregon's dynamic landscape has shaped the record of mammals, has shaped the evolution of mammals, you need to look at it across the landscape. So you need a lot of different places where that mammal record is preserved. And most of those Cenozoic rocks in Oregon, at least the ones east of the Cascades, are mostly in terrestrial environments, which means they're going to have a nice terrestrial mammal assemblage, potentially. And, you know, it's not just potential. The map on the right there is from the Paleobiology database, which you may or may not be familiar with. If you've played around with this, it's a public database of published fossil occurrences. And so all I've done there is just have it plot all of the fossil occurrences of mammals in Oregon and a little bit of the area around it, because zooming the map is not a very precise thing. You can see all of Kent's favorite places to play out there on the West Coast. But if you look east of the Cascades, you can see lots of big yellow dots, many of them sort of overlapping one another, as well as some orange ones. And again, the color code is the same. These are Cenozoic mammal occurrences, right? So these are just the published occurrences of mammals in central and eastern Oregon, right? And you can see there's a lot of them. There's a lot of places where we have fossil mammals. I'll also tell you that because this is only the published record, it's an incomplete representation of the distribution of these kinds of mammals in rocks in Oregon. Some of that is because some of these records are not published. Some of that is because some of these places aren't even really all that explored. If you'll notice, there are several dots in the sort of southeast corner of the state. I will tell you there are a whole lot more rocks that have mammals in them in the southeast corner of the state. We just haven't actually gotten to a lot of those places yet, or we have, and we haven't gotten to the point of actually publishing them yet. So work to do, and if we're going to understand the ways that the mammals have evolved through the last, say, 40 million years, while Oregon has this excellent record of terrestrial mammals, we don't just need to go to one place or a few places where they're really well preserved, but rather we need to see what they look like across the whole landscape in order to understand how change in one place or another affects the evolution of the mammals living on that landscape. All right, so given that that's my question, what that dictates in terms of my field work is trying to cover a lot of ground, right? I'm not just going to one place and digging in one hole for 2 weeks. I'm driving around basically a big lap of central and eastern Oregon every summer to try and get to different sites where we can add to the record of fossil mammals in Oregon. So as I said, we're focusing in large part on the Oligocene and Miocene terrestrial records, so the last 35 million years, which are really well represented in the record in Oregon. We're definitely working on locating new sites in some of the areas where I know that there are appropriately aged rocks at the right kind of lithologies, but where there just hasn't been exploration for fossils. But we're also going back to known sites and collecting new material. And in particular, my focus is on the remains of small mammals. And the reason for that is that if you're going to look at the relationship between animals and their environment, animals in the landscape around them, small mammals actually respond a lot more directly to the landscape than do large mammals. And the reasons for that are fairly intuitive, right? Your deer and your antelope and bison and things like that, if they don't like what's going on locally, they just wander to the next valley over or the next one after that or whatever. Whereas if you're dealing with something like a gopher or a mouse or a shrew or something like that, they're kind of stuck where they are. They could spend their entire life walking from one side of the valley to the other, given how small they are, and so they tend to much more directly reflect the local environment. So a lot of these sites that were collected in the past, this is an illustration from a site called Red Basin out in the sort of western part of the Owyhee area. A lot of these sites were collected primarily emphasizing large mammals, and I'm going back to some of the same sites and using some techniques to try and recover rodents and rabbits and shrews and moles and things like that from those sites in order to get a more complete picture of the mammals, and particularly to emphasize these mammals that might give us a better sense of how the landscape is shaping mammalian evolution. Part of this involves relocating old sites from, for example, Arnold Shotwell, who's one of my predecessors here at the University of Oregon, as well as other past workers, partially to go back and look for additional fossil remains, but partially also to collect samples for phytolith analysis. And if you haven't heard of this before, I have a colleague up at the University of Washington, Carolyn Stromberg, who is a paleobotanist, and she uses a particular technique to understand fossil floras and how the plants looked on the landscape using what's called phytoliths, which are little bodies of silica from within plant cells. The great thing about phytoliths is that they preserve in some of the same environments as fossil vertebrates do, which is not true of macrofloras, large plant remains, or of pollen. And so when we're trying to understand that landscape mammal interaction, phytoliths are really great because you can say, what exactly did the environment look like in this place at the time when these mammals lived here, in a way that you can't exactly do when you're connecting things with macrofloral or with pollen remains. So we're going back to a lot of pre-existing sites. We're also working on locating new sites and basically touring Central and Eastern Oregon looking for dead mammals. There's plenty of past work to build on. Any of you who've dug around in the history of paleontologists working on fossil vertebrates in Oregon know that we've got 150 years easily of people working out there. Obviously, I don't have Thomas Condon on here. We all know Thomas Condon was one of the first vertebrate paleontologists to point out some of these spectacular vertebrate deposits. But since Condon, there's been systematic work by John C. Merriam from the University of California, by Chester Stock in the 1920s from the California Institute of Technology, materials now held at the LA County Museum. Arnold Shotwell in the 1960s. Again, this is a picture from one of his field expeditions with a bunch of young men, mostly on the GI Bill. He in the 1960s and very beginning of the 1970s took a lot of crews out into Central and Eastern Oregon and collected much of the mammal material that we have in the University of Oregon collections today. And of course, Anybody who's been going to the John Day fossil beds for a couple of decades has encountered the work of Ted Fremd, who started at the fossil beds pretty close to the time when Arnold Shotwell left the University of Oregon, and Ted was kind of covering this Central and Eastern Oregon Cenozoic vertebrate record for a few decades before I got to Oregon. There's a whole lot of past work. There's a lot of these past sites that these folks found in the past that we're going back to and collecting new material from, trying to understand what was going on there and what's the context in which their material was found. We've also been doing work on new sites with help from people like yourselves. So we often get the heads up from people who are rock hounds and recreational paleontologists who will be out there in the field, wandering around in likely looking rocks, and we'll find new sites with fossil vertebrates. I've had several students do thesis projects on the basis of sites that were located by, folks who didn't work for the university, who went out looking for fossils because fossils are cool. And so this is my plug for the great relationship that we have with NARG. The University of Oregon's really appreciated all the help that we've gotten from NARG folks. We've had digs with NARG in the past, and we've also had NARG folks give us the heads up when they have run into fossils in the course of their rock hounding and that kind of activity. I'll share my usual shtick on this. We are the state of Oregon's fossil repository. We're here to keep the fossil legacy of Oregon for Oregonians, for all, posterity for generations. We have material that dates all the way back to Thomas Condon's work in the late 1800s, and we will keep it for hundreds more years so that all of us can appreciate that fossil legacy. So when I know y'all have been great about doing this in the past, but I'll say again, we really appreciate the way that NARG has helped us to find and recognize scientifically important fossils and to get them collected and prepared and into a repository like the University of Oregon's museum, where we can share them with everybody else. So I would not be doing the work I'm doing if people hadn't built this museum collection in the past, but we're also out there trying to build more of the record, trying to preserve the fossils that we find out there for future generations to work on, as well as for the work that we're doing. So obviously, as I said, there's a lot of areas we're working. Some of these you would have known if I had said, hey, where would you go looking for fossils of this age? The John Day is right at the top of the list. And of course, if you've been out there, you know that it's not just the beautiful green rocks like in this photograph. This is the late Oligocene part of the record there, but there's fossils from all the way from the late Eocene going up until the latest part of the Miocene in a series of different formations that preserve sort of a series of different environments through time. The same is true of several other regions. The Owyhee region doesn't necessarily overlap all that much with the John Day. It's actually mostly younger. Almost all of the Owyhee fossiliferous rocks are Middle Miocene and later. They're often affected by some of the volcanic history out there. So there's some really excellent deposits of rocks that were a result of the Columbia River basalt eruptions damming rivers and causing sediment to accumulate in the sort of backwater of these dammed drainages. And so there's a really spectacular record accumulated while the rivers were trying to find their way back to the ocean. That area, if you've been out there much, you know that it's really hard to get to a lot of it. A lot of the Owyhee is really inaccessible. That's both a feature and a bug. It means that a lot of the fossils in the Owyhee, like many of those areas, are unexplored. Right? We don't even know what's out there because it's really hard to get to. On the other hand, that's preserved them against, you know, collecting by folks who don't know what they're looking at, right? So it's preserved them from being carried off by people who might not make sure that scientifically important specimens are getting where they need to be. And so the work we're doing in the Owyhee has been really productive in a lot of cases, but it's also logistically quite challenging. So you know, that's a kind of ongoing project, I guess, trying to make sure that we get to all the areas in the Owyhee we're trying to get to. Crooked River is a place I've been working for a long time. It exposes the same rock units as we see in the John Day. So if you know the area, the South Fork of the Crooked River is basically due south of the John Day Basin. And as the crow flies, it's not all that far. You just have to make it over the Ochoco's. But getting there on the road is a whole lot longer. But many of the same units are exposed. A lot of it is a bit less studied. And so Ray Weldon and I have been working out there trying to collect some of those sites. And we've had several new sites developed in the Crooked River that were surprisingly close to existing known sites, and nobody had bothered to go over the next ridge and look what was in the dirt. So those are three areas where we've been doing a lot of work, and where we're getting a lot of different sites that are important to the work. And then there's some sort of smaller, more localized sites that we're working on, and these are just a few examples of them. There's some near Ventura, Oregon, that fill a gap in the time covered by the John Day section. So there's a period around 12 million years ago that we don't get in the John Day area, and we do around Ventura. So that's pretty exciting. We have some sites down near Paisley that unfortunately I can't talk about in too much detail. We've had some fossil poaching issues on federal land that have been kind of unfortunate, and so we're trying to keep the exact location a bit quiet, but we've been working on some sites near Paisley that I'll show some pictures from that are really exciting and preserve some of the same times as the John Day Formation does. And then one of the hardest spots to get to, but one where we've been going back to the last couple of years is Beatty's Butte out in South Central Oregon or Southeast Oregon a bit. And I've got a grad student who's been working on material from there, collected by some volunteers who work in the museum, as well as past paleontologists working for UO and other places. So a lot of places that we're going, right? We're doing a lot of driving and not staying in places for real long, but definitely finding some interesting material in the process. Okay, let's see if I can get it to actually, there we go. Okay, so this is the fun part, the kind of what we're finding, and I'll sort of walk through the places that we went this year and just give you a sense of what all we're looking at. You know, in the site that we're working near Paisley, we've actually found a lot of nice material in the past, and I'll show you a couple of things from that. But this year, most of what I was finding was rocks. There's some really spectacular ones. The rocks there are, if I didn't know they had fossils in them, I would call them primary volcanic units. They're really derived very proximally to a volcanic vent. They're basically tough with, strange enough, fossil bones preserved in them. And so this year, I was working with some geologists out there, trying not to find fossils and trying to do a really thorough job of describing the rocks and the sedimentary environments in which the rocks, in which the fossils are occurring. So some really spectacular views and climbing some really, really steep slopes and trying not to fall off of them while collecting geologic data out there. And some really spectacular rocks, things like this, these big pieces of pumice preserved in an ash fall out there. There's another ash fall layer up here, and then there's another one up here. Oh, and this thing down here is a big ashfall. So would have been a really bad place to be most of the time. I'm pretty sure you've been raining, hot ashy death on you kind of on a really regular basis out there. But we've got a nice description of the sedimentary environments that we're finding these fossils in. And while we didn't find much this year, we've definitely found some really spectacular things there in the past. Given my interest in small mammals, I'm showing you some CT data from a spectacular little skull of this rodent called Mylogallodon. It's just the snout and the palate of the skull. So you can see these are the big incisors in the front here, and these are the cheek teeth. So you're sort of looking at the front end of the face, and then the cheekbones, just the front of the cheekbones. So this is the orbit right here. And we're missing the back of the skull, but we have this lovely CT scan of the skull, and you can actually see in the section here that goes through the nose, you even have the nasal turbinates preserved. So these are the little thin little bones inside the nose of this thing. So a really spectacular little skull. We've got some lovely skulls and partial skeletons of camels and oreodonts, and we took a nice palette of a calicotherium out of this site a couple of years ago. So really beautiful material from this site. So we were just trying to get an idea of geologic context this year. This year we spent a little bit of time out at the Crooked River collecting a few sites. A lot of the material we're looking at in Crooked River is Middle Miocene in age, which is about 15, well, actually it's about 17 million years in the Crooked River area. That fauna has horses in it, like the one that, actually not at all like the one that we saw at the beginning of the meeting here, but actually some of the first hypsodont or high-crowned horses occur in the Middle Miocene. But that assemblage, one of the things that's interesting about the Crooked River assemblage is that unlike the Maskell assemblage in the John Day area, the Crooked River Maskell is dominated by this thing Dromamerix here, and another relative of it's called Ractomerix that are more deer-like. So we found some nice teeth of these guys this summer. We're also finding a lot of rhino teeth. So we get lots of rhino material out there from a thing called Teleoceras, which is a big hippo-like rhino from the Middle Miocene. As I said, a lot of our emphasis is small mammal remains, and in the Crooked River area, there's a site called Cave Basin that has these anthills. This is a nice section through one of the anthills out there. And one of the best ways to collect small mammal remains out there is actually to scrape the sediment off the top of the anthills, because when the wind blows out there, it blows the anthills away. So the ants put little tiny rocks on top of the anthill to hold it down, and they'll get those out of the sediment. And a lot of the time, those little tiny rocks are actually rodent teeth. And so we take just the top thin layer of sediment off the top of an anthill, and we run it through some fine mesh, and all the fine sediment goes through. We float off all the plant bits that the ants were collecting for food, and what's left are little rocks about the size of mammal teeth. And I've got volunteers working in my lab to pick some of that matrix and find all the little teeth from there. So we have a really spectacular assemblage of small mammals out of the Crooked River that's telling us a lot about what was going on. One of the things it's telling us is that Oregon, unlike the Great Plains, was much more forested 16, 17 million years ago than we see in a lot of the record of North America. It was closed forest out there 16 million years ago, which is interesting to think about. Oops, that was not what I meant to do. Just a sec. We're also working in some of the John Day Formation in the Crooked River. And this guy right here is an example of this. It doesn't look like much. Mostly you're looking at sediment, but this right here is what a really nice root fossil looks like out there. Doesn't look like much on the surface because we haven't actually dug in yet. This turned out to be part of a skeleton of an oreodont that we collected at the end of the day on our last day out in Crooked River. So two shoulders, basically. So the proximal humeri on both sides, and a little bit of the shoulder blade, the scapula, and some tooth and skull bits kind of weathering down the hillside. But it often looks really unimpressive when you first find things there. You're like, oh, there's like 3 scraps, and then you poke around, and then there's more scraps, and you get a little deeper, and oh my goodness, like half of the critter is there. So pretty good hunting, and this was on a site called Larkspur that's generally not been very productive. And so we had some pretty good luck in Crooked River this year, even in the John Day Formation, which is less productive in a lot of places out there. Here's the site. This is Larkspur. Here's a couple of my field hands, these little tiny gentlemen here. The one in the dark shirt there is 6'1", just to give you a sense of scale. So lots of outcrop to walk, lots of area to cover looking for fossils. And you can see it's beautiful landscape, but also, as you can imagine, this is very slippery stuff to work on. So you can spend a whole lot of time sliding down a hillside, trying not to land on the fossils. From there, from Crooked River, we went to Gentura, and we were working in some of the slightly younger rocks there. So where in the Crooked River, we're working mostly in the John Day age things, which are about 27, 28 million years old, something like that. And then the Middle Miocene Mascal things, which are about 16 million years old. Gentura is more like 12 million years old, so it's a little bit younger. And the fauna is pretty profoundly different. I have an illustration of some of the modern fauna that we encountered while we were out there. This little tiny friend had caught himself a mouse that he was a little bit too small to eat, but he was darned if he was going to let us walk past and get in the way of his trying to eat it. We came back later and the mouse was there, and then we came back later and the mouse was not there. So I'm not sure whether he ended up eating it or if somebody else came and stole it from him. But we did find some really nice material in the Gentura formation out there from some of these camels that dominated the assemblage at that time. So where the Middle Miocene is all full of a diversity of horses, and these horses that are starting to be grazers, you go, 3 or 4 million years later, and Oregon's fauna is dominated by camels. And in particular, there are these really extraordinarily large kind of giraffe-like camels called Epicamelus. This is a little illustration of some of them that were literally the size of small giraffes. And so we were finding these honking big teeth from these sort of giraffe-like camels out there. We also found some nice material of the Gomphotherium that's known from the Gentura area. So there's a big kind of mastodon-like elephant relative. And we found some bits and pieces of that too, although they didn't photograph very well. So apologies for not sharing that in person. The other place we went out in the Gentura area is actually back to that same Middle Miocene age, so around 15, 16 million years old, a place called Red Basin. This is sort of neat. This is a picture of a bunch of Shotwell's students quarrying in the site that is Red Basin back in the 60s. And you can see, here he's got this little tent set up over this little bit of exposure, which you can see is probably like a meter worth of stratigraphic thickness there. Not a whole lot of it. And if you look at this lovely photograph of the site, you could be almost anywhere in the Oregon high desert, right? There's like sagebrush and there's this sort of rolling hillside in the distance. And so as like photographs of fossil localities go, this is the next best thing to useless. This is a site that fortunately he had a pretty good description of the locality that allowed us to get out there. But this is what it looks like today. You cannot see the quarry scar really at all. This is actually a road right here across the middle of this. It looks just as unprepossessing now as it did then. It is not a place. I pulled the cars up and my students were like, is this seriously the fossil locality? You've got to be kidding me. But we went out and it's a place I've been before. And so we went out and had some pretty good collecting. Again, we're finding horses and Dromamerix, those little deer-like creatures, and a few rhinos. But one of the things that I really like about Red Basin is that it actually has some really nice small mammal assemblages, because if you've got an outcrop in the middle of the sagebrush, you've got a lot of ant hills. And so we would go out with these little pin flags and drop pin flags in the ant hills. And this was one where the ants got very excited about the pin flag. So I thought you'd get a kick out of the ants climbing up and down the flag here and assaulting my pin flag. So again, just as in Crooked River, we were sacking up some of the material that the ants collected for us, ants being the best paleontologists out there. And we're going to be spending the next month or so screen washing and picking a lot of that to see what comes out of the assemblage there. So another of these sites that we're getting really nice small mammal material from. From Gentura, we then drove up through John Day, gave my students a chance to do some laundry, and then headed out to Unity. Unity has some outcrops that expose rocks of the same age as the Gentura material that had all the camels in it. So we're back to that like 12 million-ish year old deposit. If I remember correctly, OMSI at least used to have a skull on display of a proboscidean from Ironside, which is the same formation as we're getting out near Unity. Unity is a little tricky because a lot of the sites are on private land, and the landowners out there are not always super excited about having people go stomping around on their land. So we're working on some of the sites that are on BLM land that we could get access to. So this was one of the sites that we were working on. We were working with a map that was maybe not real great, so we weren't totally sure we were in the right place. And we wandered around for a couple hours finding a whole lot of nothing, and then went up just the right little gully and found a whole lot of pieces of tooth, just tooth scraps from something like this guy here, a thing called Gomphotherium. So nice big proboscidean. And I think that's the only day of fieldwork I've ever had where almost everything I've collected has been an elephant relative. It's been a proboscidean fragment. You got probably a couple of partial teeth, nothing that would get anyone all that excited to look at individually, but helped establish exactly where the fossil site is. And we've collected some material that we're hoping to screen wash in hopes of finding some things a little bit smaller than this Gomphothere here. We finished up the trip in the John Day area, and we went through several sites in the John Day Formation. One of them is called Larkspur, or sorry, not Larkspur. This is Greyface Bluff, which is a site that was collected back in the 60s by John Rensberger from then the University of California. He subsequently was at the University of Washington. And this is in the John Day Formation itself, and it produces some really spectacular material, including these lovely little gophers. We had, I think, half a dozen skulls in a day, as well as several little jaws of these Enoptychus gophers, which are very common at that time, and which are one of the things that tells us that the John Day was probably a relatively, open habitat, relatively sort of drier than the Eocene time that preceded that. We also found some nice material of Paleocastor. This is a skull. The skull itself doesn't have any teeth, but then you can see both jaws. So here's the right dentary, and here's the left dentary, and you can see they've got all the little molar teeth in them. So both jaws and the skull, weirdly enough, the skull has the jaws sort of like stuck on top of the head, but it was all in one little concretion there. So some really nice material of one of these burrowing beavers from the John Day that are not real common in the assemblage. So it's fun to find that up at Greyface Bluff. We went to a couple of other sites. We were very fortunate. All of these sites required access across private ranchers' land. And these folks were really kind to just say, hey, you can drive across. Here's where we want you to park, and yeah, that's no problem. Go do your work. And in a time when people are very suspicious, where particularly those of us working in an academic environment are maybe not the most popular people among the folks out in Central and Eastern Oregon. We had a great experience with some of these landowners, really encouraging us to go and do the work. So a lot of appreciation for some of the folks that gave us access. All of that is sort of, we have to acknowledge that there were some challenges out there. One of the major challenges that we're all thinking about this time of year has to do with wildfires. And we certainly experienced some of the difficulties with that. One of the sites we were hoping to go and work on out in the Owyhee caught fire right before we were about to go out there. And so we made the judicious decision not to take half a dozen university students out into a wildfire zone. And so we had to give the Owyhee a pass for the time being. When we got done in the John Day, this is a fire just northwest of Spray, so about 20 minutes from where we were camping, that caught on our last day out in the field. So definitely one of those years where we're sort of tap dancing around the wildfires and trying to make sure that we are really careful about what we're doing out there. We don't whack a big outcrop full of chert with a steel hammer at the wrong moment and start a fire ourselves or anything like that. So a lot of concerns with how dry it is out there. It's going to be a rough year, I can tell. The other challenge, on the one hand, we had some great landowners who were really helpful to us. On the other hand, we had at least one site where we've been stonewalled for several years now. This is one of those sites near Unity. There's a little spot in this yellow patch. This yellow is BLM land, and you can see here's the nearest road in Hereford, and it's landlocked. It's surrounded by private land here. So to get to this patch of BLM land, you have to get across private land. And unfortunately, there is no easement. And so it requires permission from the landowners. And in this particular case, this is a site we've been trying to get to for several years, and we've been stonewalled by the landowner with the easiest access. I have finally started to get a conversation going with another of the landowners who can get us there from another route, but we didn't manage to make it work in time to get out there this summer. So we're going to go possibly another year without quite getting to this site. So work to do on access issues as always in this part of the world. You just got to work with people. You got to convince them that what you're doing is worthwhile and is safe and is okay, and you're not going to do damage to their land. I totally understand why they're worried about this stuff, but it is an ongoing challenge out there getting access to some of the sites. On the other side, I have to say there's some really great people out there who've been helping with logistics, with figuring out how to get to places, with access and support. I've got Nick Famoso from the Park Service here, but he's definitely been one of the ones who's helped us get access to sites, but also a whole lot of folks with the Bureau of Land Management who have worked hard to help us figure out the logistics of getting out there, and where we need to be and get us the permits that we need and so forth, so that we can do the work right. In order to collect on federal land, right, you have to have an appropriate permit. That permitting takes a lot of time. It takes a lot of people getting all of the right permissions, double checking to make sure that we're not going to be going out on places where we might do damage to other kinds of resources. And in a time when, a lot of these governmental agencies are understaffed, these folks have really, pulled out all the stops to make sure that we get access to the places we need to at the time when we're trying to go out. So they've been really fantastic, really great partners in the work we're doing. The other folks I really have to shout out is the Friends of the Owyhee. They're a nonprofit group that works on land issues around the Owyhee and is advocating for people to, to safely and in a way that is good for the land to make use of the Owyhee and to experience the natural beauty there. And Friends of the Owyhee have been amazing in helping us figure out the logistics of getting to places that are absolutely a long way down the arse end of nowhere. It's really hard to get places in the Owyhee because a lot of the roads are really rough, really rocky, and some of the places we need to get to, I don't have time to drive 7 hours out there and then spend another 3 days trying to find my way into the right canyon. These guys live out there, work at other jobs, they volunteer with friends, and these guys will take their trucks and their four-wheelers and their mountain bikes and their hiking boots, down all kinds of, roads and places where there are no roads and figure out the easiest access to the places we want to go. I'll send them a point on the map with a picture from the aero photos of an outcrop, and I'll say, I bet this outcrop has fossils in it. Tell me how to get there. And these guys have figured out the logistics of doing it. So pretty amazing folks. I really have to express my appreciation to all the work that they've done in a place that's really hard to get around. More work to come this summer. Here on the left, that's a picture from Sucker Creek. We're going back out to the Owyhee, assuming there's enough water in the river in September. I'm actually doing a low water raft trip down the Owyhee to get to some outcrops that we have established are not accessible by road. And so we're going to do some fossil prospecting from the river out there this September, assuming that the hydrologic conditions cooperate. And we've got ongoing work as well out in the Paisley area and in Crooked River, and my collaborator Ray Weldon here, who's been an absolute rock of a colleague. He and I are planning to do some more work where he helps me with the geologic understanding of what's going on, and I've been working on the fossils out there. So more of that to come on some shorter trips this the rest of this summer, but still sort of work in progress there. So with that, thanks to all of the people who have helped facilitate the field work that we've been doing out there. My collaborators and colleagues, all the students at the U of O who've come out, many of them, unpaid, having no idea what they're getting into, come out with me. We collect fossils. They do what I tell them to, and their payoff is usually a free meal and the joy of picking up some, weird little scrap of mammal from a really obscure hole in the ground. So I really appreciate them, as well as all the folks who've helped out with the logistics of getting to a lot of places in very short order. So with that, happy to take questions and hear what you want to talk about.
I got a question, I guess. Have you heard anything about the university trying to find more room for fossils?
This is a continual conversation. Right now is a very challenging time for that. As you might know, federal budgets have been cut in a major way. The state budget is dead flat, and student enrollment has dropped off because we've hit the point where the recession in 2008 caused people not to have kids. And so we suddenly have a much smaller class graduating from high school this year and the next year after that. And so the university budget is really quite tight. So right now, every time I bring up the issue of finding more space for the fossils, I get grumpy noises from the people who handle space because they tell me there is no money. I'm a squeaky wheel, Kent. You know me. They have a hard time getting me to be quiet about it. But we're working on it. The new museum director, Todd Brady, is aware of the need, and he's been a squeaky wheel as well. I really appreciate his advocacy, and I think it's just a matter of wearing them down, right? I think there are places they could make space for us, and it's just a matter of getting them to understand the importance that these collections have, in the long term. I think everybody in this room knows how important fossil collections are. We understand that preserving fossils for future generations is like a critical thing that we do as human beings, right? And our understanding of the natural world requires having these materials in order to understand what came out of where the earth has been, right? But right now, the administrators are not ready to make the moves in that direction. So, we've had some great support from the museum donors and the board there. I'm getting some support from them in ways that are useful, but we're not at the point of getting the new space yet. We'll
I've talked to Todd a little bit, and I'm just trying to be a squeaky wheel too, because I've got this collection that I want to get there, and
yeah,
I'd like to have it done in my lifetime.
I'd like to have it done in your lifetime too, Ken. I'd like to have it done sooner rather than later. I think Todd would too, and he's just trying to figure out how to, what the landscape is, and get to know the right people and find the right message to get them to do it. I think it can be done. I think I have some ideas about how it can be done. Currently, they don't like that answer. But if I keep saying it long enough, maybe they'll start liking it better. But I appreciate your squeaking at them too. I think the more of us that are making it clear to them the importance that these resources have. I mean, that barn full of fossils you got is a whole bunch of really important material that we as Oregonians need to have here as part of our state natural heritage, right? That's part of our patrimony here, right? And so, finding a way to get the university to understand that part of their responsibility as a state repository of fossils is to make a space to put this in. We'll get there, but we'll have to keep squeaking a little while longer, I think.
Okay, well, I'll be waiting.
I know, man. I promise we'll get there, but it's just gonna take some work.